Sorry about all the confusion earlier, like in the week. That was fun.
That was all good. Sorry I couldn't come. The first meeting this week.
It's all right.
Yeah.
Super busy.
Yeah. No, the first meeting was kind of a mess. We tried it on Monday and it didn't work, and then we tried it again Tuesday, and we got some stuff done.
Yeah.
Well, half of us got some stuff done.
Yeah.
Were you guys at least able to take the quiz?
Yeah.
Yeah.
Okay,
I
good.
just marked that I wasn't in the group meeting, so.
Yeah, that's too bad. But you tried the first time, right?
Yeah, I did. It's okay though.
Okay. How you guys feeling about today's stuff?
Pretty good, except for the part 2. Like, it didn't give me numbers in it. Like, in all of the, like, number 4, 5, and 6.
Huh.
It didn't give me numbers, and so I couldn't even do them. Like, it was the same question, like, 3 times over. And so I couldn't even do it.
That's weird.
Yeah, so I don't know.
Yeah, that's really weird.
Then I looked at the answer key, and it, like, gave me answers, but it didn't, like, it still didn't have the numbers in it. And so
Right.
I just wasn't able to do part 2, but it doesn't seem like it's too hard.
Yeah.
That's cool. Do we want to go through it together?
Yes, please.
Or-
'Cause I struggled. Well, the homework was fine, and then I started doing the group meeting just to see, and I don't know.
It was less fine, huh?
It was less fun.
All right. Well. So do you want to do the quiz, or do you want to start off with like the part 2 for the preparation stuff?
Doesn't matter to me.
I don't care. Whatever, like, we could do part of part 2 or like whatever we have.
All right.
I guess like
That sounds good.
need help with or whatever.
Yeah. Let me just pull it up here real quick. I cannot believe that tomorrow's Friday already.
I know,
it's
it's
I know.
crazy. Gosh.
So it went by
It's
fast.
so fast.
Complaining or anything. Yeah. I'm not complaining, but it snuck up on me, so kind of a nice thing though. At least it's not Monday tomorrow.
Yeah. I'm glad it's Friday.
Yeah.
That's
Yeah.
true. I'm like excited it's the weekend, but at the same time not. I have 2 tests this
Yeah.
weekend, so I'm like,
Oh.
ugh.
Oh, what classes?
I have Biostats 65, and then we have a test in this class. Or is that next
What?
weekend?
That's next week.
Next weekend? Oh, next week? Okay. Well,
Yeah.
That's
just
good
Biostats
to
65
know.
then. Yeah.
Oh,
Do you
yeah.
know how the tests in this
Yeah.
class are supposed to work?
I don't know. I'm assuming that they're online, but I don't know if we have to go to
I
the
think
testing
it is
center
online.
or if it's like just take it or I don't know.
Hmm.
I would think that our teacher would like tell us soon. So I don't know.
Yeah. To be honest, though, I don't even really look at the emails that he does send, so I'm.
Yeah. I feel like there's a lot of them, so
Well, I'm just trying to pull my thing up, that paper with the part 2 stuff on it. So if you guys have it, we can get started. It's like loading right now.
okay.
Who's partying in the background?
Hi.
Sorry about that.
Oh no, that's fine.
Yeah.
It's all good.
You guys can still do your thing.
Sounds exciting.
He's getting his snowboard stuff.
Oh, nice. Is he going right now?
No, he's going tomorrow.
Oh.
Yeah, it's a little late to go today.
That's what I was thinking. Like, man, that's commitment right there. I don't know what to do with my computer, guys. This is so slow. Video chat thing. It works fine all day, and then I start this, and it goes crazy.
It's just too much for it.
Yeah. I give up. Like, I can see it on my page. It's just frozen now, so I can't scroll past part 1. Okay. Part 2. That's kind of long. So, should we I'll just read it then, and then we'll go through them, or?
Yeah, I guess that sounds fine.
Yeah.
Alright. Cool. Suppose pair computing sold an average of, what is that? Is that the mean?
Yes.
Okay, of 45 P phones per minute in 2011. Yes, that means they sold 23,652,000 P phones in 2011. With a standard deviation of 10, they looked at their P phone sales data and determined that they are normally distributed. So question 4, samples of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of the sample mean? Is that what that symbol means?
I think so, yeah.
Okay. It would be
Yeah,
normal,
so
right?
mine
Mhm.
didn't have the 45 or the 10 or the n or the sample mean.
Oh,
Oh my
really?
gosh.
Yeah, it just
Well,
didn't
that
give
would
me the
be
numbers.
hard.
Yeah, so I tried to look at it and I was like, this makes no sense.
Did yours say like preparation assignment revised?
Yeah,
Oh, that's weird.
yeah,
Huh.
one. Maybe it's because
Weird.
it's on Google Docs, I don't know.
Okay. Yeah, mine has numbers on it. So
Yeah,
yeah,
I would say
question
that's
number.
normal.
Yeah.
Yeah.
So answer to 4 is that it would be normally distributed. 5 sample sizes of 40 are taken from the normally distributed data. What is the shape? It's still normal, right?
Mhm.
Okay, a sample size of 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed mean is less than 40? So now we get to use our cool little applets, right?
Yeah.
Okay, this is the part that confuses me then. So do we have to find the z-score and everything first? Anyone? Can you hear me?
Yeah.
Yeah.
Okay. So do we have to find the z-score? Or,
Yeah, and then you put it
okay,
into the applet.
okay.
Okay.
So for 6, the z-score is -1.
Mm-hmm.
Okay. And so then the probability would be 0.16.
Yeah.
Wait, how'd you get -1 for the z-score?
So the z-score, it's 40 minus 45.
Sorry, I didn't hear any of that.
It's 40 minus 45 over
Okay.
10 divided by the square root of 4.
Colton, stop. Colton.
Does that make sense?
So 40 minus 45 over 10?
Divided by, yeah,
The whole bottom is 10 divided by the square root of 4.
yeah.
Okay. And that gives you 1.
Mm-hmm. -1.
Okay,
Negative
cool.
1, yeah.
Right. Cool.
Okay.
Yeah. And then you plug it into the applet.
Yeah, and then so it's 0.158.
Yeah, 0.1587.
Yeah.
Okay, so question 7. A sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed sample mean is greater than 35 and less than 55?
So I got a z-score of -2 when it's
Mm-hmm.
greater than 35, and then a z-score of 2 when it's less than 55.
Yeah.
Yep, same here.
So
And then the probability,
it's 0.9545.
Mhm.
Is that
Yeah,
what you guys got?
Mm-hmm.
0.9545.
Cool. Awesome. You still there, Shayna?
Yeah, sorry. My husband was playing with the dog, so I had to mute it.
Oh, all right. Awesome. You following along?
Yeah, yeah.
Yeah. Cool. Just making sure we're
He's
not
done
losing
now.
things.
I told him to go downstairs.
Awesome. So everyone clear on 7 then?
Yeah.
Yep.
Okay, moving on to 8. A sample of size n equals 25 is taken from the normally distributed data. What is the probability that the sample mean is greater than 41 and less than 39? Did you get a z-score of negative 0.8?
I got a z-score of -2
Oh,
for
man.
the first part. For if it's greater than 41. And then
Wasn't that the z-score for the last one?
2. But the n changed.
Right.
Yeah, that's what I got too.
Okay, cool.
Yeah, me too.
Okay, sorry. I'm a little confused here. So it's 41 minus 45 over 10 divided by 5?
Yes.
Okay,
Yeah.
cool. I know what I did wrong then. Awesome. Okay, cool. Oh, did we get for 49? Is it positive 2?
Yeah.
Awesome. So same probability then?
Yeah.
Yep, yeah, it's the same
0.935.
exact thing.
Okay, cool. And then 9, a sample of size n equals 25 is taken from the normally distributed sales data. What is the probability that the observed sample mean is greater than 50?
5 halves, or 2.5 for the z-score.
Yeah.
Yeah, that's what I got.
And the probability is
0.987 or 0.988?
it should be I got 0.0062.
Yeah, me too.
Oh, right. So we
Greater than
meant greater than. Okay.
Yeah, greater than.
My bad. Yeah. I'm glad I had you guys around. I make lots of little mistakes like highlighting the middle instead of the right-hand side of the thing. All right. Pair computing sold an average of 40 P phones per minute in 2010 with a standard deviation of 12, and they looked at their P phone sales data and determined that the distribution is right skewed. Samples of size n equals 4 are taken from the right skewed P phone sales data. What is the shape of the distribution of the sample mean? That would be right skewed, yeah?
Yeah.
Yep.
Awesome. And then 11, samples of size 40 are taken from the right skewed P phone sales data. What is the shape of the distribution? That would be normal,
Normal.
right?
Normal.
It's over 30, so it's normal. Okay, 12. Is there a theorem that justifies your answer to question 11? Heck yes, there is. The central limit theorem, right?
Yeah, that's the one.
Okay, 3 more. Let's do this. 13. A sample of 4 is taken from the right skewed p-phone sales data, and you want to know the probability that the observed mean is less than 35. Can you compute this probability using the normal probability output with the information you have, and why? I would say no.
Yeah, because it's
Yeah, 'cause
not
it's
normal.
skewed, yeah.
Yeah, it's definitely skewed. Okay, so question 14, a sample of 36 is taken from the right skewed p-phone sales data. What is the probability that the observed sample mean is greater than 36.5? So for the z-score, I've got 1.75.
Yeah, negative 1.75.
Yeah,
Yeah, negative.
Okay.
and then for the probability, I got 0.959.
Yep, me too.
That's what I got.
0.9599.
Cool. Sounds good. All right, last question. A sample size of 36 is taken from the right skewed sales data. What is the probability that the observed sample mean is between 37.5 and 42.5?
You said the sample size is 36, right?
Yeah.
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 I just don't have that on my thing.
I got negative 1.25 for the z-score and 1.25 for the other one.
Mm-hmm.
And the probability 0.7887.
What did you get for your probability again?
0.7887.
I got, yeah.
Oh, yeah.
Yeah, that's what I got.
Finally doing right.
Mm.
You figured it out.
Yeah. It's about time. Okay. Any questions so far?
I'm good.
I'm good.
Yeah, me too.
Cool. So we are ready for the quiz?
I think so.
I think so.
Yeah.
Okay, Shane has got me scared to take it, so this could be good.
You're welcome. I think it's just because in the questions there's so many different numbers to choose from.
You have to really know what you're doing.
I don't know which ones to plug into where.
Right.
We'll help you.
All right. Hey, just a quick question. Like, every time I post these videos and stuff on the one page, like, all the other people who post, there's always comments like, I attended, I was there, all that stuff. Like, are we supposed to put that we were there?
I'm not sure. Like, I've seen that.
Yeah,
Yeah,
I've seen that too, and I don't know.
I don't know. I
Okay.
figure since we put in the
I
quiz
figured,
that we were
yeah, we
there.
put it in the quiz. That what's the point?
Yeah, and I just figured since I'm the one who was uploading it, I think it would be kind of obvious I was there.
Yeah.
Well, yeah.
I don't know.
Like, I was there.
Well, I mean, like if you didn't believe us when you put it on the quiz, like
Yeah.
you could watch the video. But
Yeah.
I can see, like, maybe if you had problems or whatever and you needed help doing it, you could
Yeah.
yeah,
say
maybe it's just
something
like another
that.
resource
I
you
think
can
we'll
like
find.
communicate with your group to see like, oh, we're gonna meet this time, but
Yeah.
Okay.
phones and emails.
Cool.
I
So
think we could.
Hey, you weren't kidding. There is lots of numbers in these things.
Yep.
All right, let's get started then, huh? Number 3, use the normal probability output to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places.
Okay.
I got 0.175.
Yep, that's what I got too.
That's what I got.
All right. 4. The United States Coast Guard assumes that the mean weight of passengers in commercial boats is 180 pounds. The previous tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. Oh man, that's a pretty big standard deviation. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also in values that are as far away from the mean as ours in the positive direction. Oh, okay. I get it. So we have the z-score of that 177.6 pounds, and then we enter that into there and find to the left or right, yeah?
Okay, gotcha.
Yeah.
Does that make
Yes.
sense?
Yes.
Okay, cool.
Then what did you guys find for the z-score?
Negative 1.92.
Yeah, that's what I got
What
too.
was it?
Mm-hmm.
What was it?
Negative 1.92.
Oh, okay. Whew, I thought
Because I
something
thought I was way off.
Yeah, I was
Those were
just a
some
little
weird
confused on
numbers.
that one.
So
Okay.
probability would then be
So would we find it to the left of the z-score?
so we
Over
find it
there?
to the left of the z-score and then to the right. So it said make sure you find it for both extremes. So the
Okay.
Oh,
left
yeah.
of the lower one and
Above
the
them.
higher one.
So 0.0549.
Yeah, and so
Yeah.
to the 3 decimal place. Wait,
0.055.
yeah,
Okay. That's what I got.
sweet.
Sweet. Okay. I'm not as
That
lost
was
as
a
I thought
weird
I
one.
was.
That was like so many numbers.
I know.
Yeah, I was like, what the heck?
I mean, I guess you used them
Okay.
all, but
Okay. Should we move on?
Yeah.
All right. Which of the following have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample mean, and this cannot be determined from the information given.
9 observations.
Shoot, I don't know.
Mm-hmm.
Let's say this can't be determined from the information given, but I feel like that's the easy way out, and no one ever puts the easy way out.
that's what I was thinking too.
But like, so say for example, it's a left skewed or a right skewed population, and we get 9, what was it, 9 samples,
Yeah.
Observations, yeah.
9 observations, then those are going to be some pretty right skewed observations, and the standard deviation would be different. I don't know. I don't even know.
Hmm.
What do you guys think?
I was thinking it couldn't be determined as well.
Yeah, me too, because that's.
You don't know if it's skewed or not.
Yeah.
Okay, so we put in that one?
Yeah.
That's my vote.
Okay. Anyone have any objections to that?
No.
No.
Okay. All right, cool. Which of the following results implies that the spread in the sample mean decreases as the sample size increases? This might change the answer for the last one.
Is it the law of large numbers? Sample size increases.
Maybe. I feel like that was on Monday's stuff, though. We didn't even read about that
No.
today. That's not
Yeah.
cool. Okay, so central limit theorem is that if you have a huge sample or population size, then a huge sample size is going to be normally distributed, yeah?
Mm-hmm.
And then the law of large numbers means something else.
Hmm.
The law of large numbers is that if the sample size is large, then the sample mean will typically be close to the population mean. This happens because the standard deviation will get small.
Wait, so the standard deviation gets smaller as the sample size gets
Bigger.
Yeah.
bigger. Okay, so small sample size, big standard deviation. Big sample size, small standard deviation.
Yes.
Yes.
In 5, 9 is a pretty small sample size. So would it have a larger standard deviation? Or do we still think we can't tell because we don't know what the graph looks like?
I'm thinking it still can't be determined.
Yeah?
I don't know.
Why is that?
I don't know. That's my guess.
Okay. I was thinking, like, based on the law of large numbers thing we just read, I was thinking it might be that the distribution of individual observations is going to have a smaller standard deviation because we have a small sample size of just 9.
Mm-hmm.
And so since it's a small sample size, it means that the standard deviation for that's going to be larger, I think. Or I'm totally understanding that wrong, and I have no idea what I'm talking about, which is more likely.
So it sounds like when the sample size is large, then the standard deviation is smaller.
Yeah. And so since that sample size is small, it's going to have a larger standard deviation than the individual observations.
That makes sense. Switching my vote. I think you're right.
All in favor?
I think you're
Aye.
right. That
Yeah,
makes
I think
sense.
you're right.
Any opposed? Okay. All right, so 6, the following result implies that the spread in the sample mean decreases as sample size increases is definitely the law of large numbers then, yeah?
Yeah.
Mm-hmm.
Okay,
Yeah.
cool. If we get 5 wrong, I'm so sorry. I just want
okay,
y'all to know that now.
We all voted.
Yeah. Okay, so scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and standard deviation of 8.8. Use this information to answer questions 7 through 10. So question 7, Diane earned a score of 160 on the quantitative portion of the GRE, which is the z-score, or what is the z-score for Diane's score? Round your answer to 3 decimal places.
I got 1.045.
That's what I got.
That's what I got.
Wait, hold on. How did you get that? Do we have a sample size?
No.
No, it's just her.
Oh, so the sample size is 1?
Yeah.
Mm-hmm.
So the whole standard deviation divided by square root of the sample size thing is just this divided by standard deviation and leave it at that.
Yeah.
Mm-hmm. Yeah.
So 9.2 divided by 8.8. And did you say you got 1.045?
Yep.
Mm-hmm.
Yep.
Yeah.
Cool. So I guess yeah, all right, sweet. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So we already have our z-score.
Yeah.
Yeah.
I got 0.148.
That is what I got as well.
Yep, me too.
Okay.
All right, a random sample of 5 students was selected to take the GRE. Their scores are those numbers there: 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? Oh man, does that mean we have to find the mean too?
Yeah.
That's just annoying. Did you get 160 as the sample mean?
Yeah.
Yeah.
That would be the same z-score as before, wouldn't it?
Yeah.
We were looking at
Well,
160 before, weren't we?
But
that
it's a
makes
sample of
sense.
5 students.
Oh, just kidding. There's a sample of
Yeah.
5.
Yeah. Mhm.
Did you guys get 2.338?
Yeah, that's what I got.
Mhm. That's what I got.
But I got 2.
Yeah, that's what I got. Sorry.
What happened to Nate? Did we lose him?
He pieced out.
There he is. Maybe. Nate, are you there? Hmm. There he is.
Hey, sorry about that.
No, you're good.
Not sure what happened there. The number 10?
Yeah.
Yeah.
Was it 0.0097 or 0.0? What would that be at 3 decimal places? 0.010 or 0.01? Never mind. Whatever it is. What is it?
0.097, so 0.010. That'd be right.
Okay.
Wait, this is for number 10?
Yeah.
Yeah.
Right.
Is that what you guys got? 0.010 once you rounded it?
Yeah.
That's what I got, yeah.
Oh, yeah.
Okay.
Yep.
I'm not sure why, but I'm always so like skeptical when I round decimal places. I'm pretty sure I'm doing it wrong every time. Okay. How long was I gone? Did you go on to number 11? I don't feel like I was gone
No,
that
you were only
long.
gone for like a minute or so. wasn't very
All right,
long.
cool. Sweet. Okay, so suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. Well, that's good. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable sample mean, which represents the sample mean of the 81 students who were selected? Approximately normal?
Be normal because
Normal.
big sample.
Yeah.
Okay. Cool. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? What?
These were the confusing questions I was looking at. I was like, what?
You're right, that's confusing. Wait,
Parent
does that...
population?
No. Yeah, that could be drawn from the parent population. So, I don't even know.
What's it even mean?
Would it just be 3.5?
I think so. Is it just asking for like us to say what it is?
Yeah, I guess. So what is the mean of the distribution of the sample means? So like you've got, well, so you've
From the
got your
parent
parent
population.
population. So you've got the parent population that is left skewed and the mean is 3.5. And so it's saying if we took 81 of those just 81 random students' GPAs, what would the sample mean be of those random GPAs?
So 3.5.
I don't know. Would it be?
I think so.
Like, I wouldn't know how else to answer that.
Yeah, me neither.
I'm saying to round it to one decimal place.
So it probably is 3.5.
Yeah.
Okay. Yeah, I've got no idea on that one. So 13. What is the standard deviation of the sampling distribution of the random variable sample mean? The mean of the 81 students are selected. What? Shoot, I have no idea. Does anyone remember learning about this?
Nope.
No.
I don't know. Um, would it just be 0.7? Or
It's
is that
around
like
3 decimal places.
a way to find it?
I don't know, guys.
Like I see that N is 81, but what's the other one like? I don't understand.
I'm trying to scroll through the textbook thing to find anything. Down in step 3 in the experiment, they've got a right skewed histogram thing. I'm not sure if that could help at all.
We're still using the data above question 11, right?
Yeah.
Yes.
So would it be 0.7 divided by the square root of 81? That's how you find the standard deviation.
That would give us the z-score, right?
No, because we didn't. That would be like the bottom of when you find the z-score.
Wait, sorry, what are you saying then?
Where did I see that? So the standard deviation of the random variable x is a little like O thing, I don't know what that's called, and then divided by the square root of n.
So would it be 0.0778?
I didn't do it yet, but 0.7 divided by square root of 81. Is that what we're supposed to do? I don't know.
Sounds right.
Then I got 0.078.
Yeah.
Let me try that real quick.
Can you explain why we're doing that?
I was just looking in the textbook, and it was
that's the
the
formula.
number 2 review of sampling distributions. Like 4 bullet points down, it says the standard deviation of the random variable x is the standard deviation divided by the square root of n.
Oh, okay, cool.
That's where I
Yeah,
found. I don't know if that's right,
That makes
but
sense to me.
That's
all I'm
as
seeing.
good a guess as any, I guess.
Okay.
Wait,
Yeah, because
so
I mean, it makes sense.
what was it?
0.7 divided by
0.7
square root of 81. I got 0.078.
Okay, cool. That's a good answer.
Sounds good.
Alright, so 14. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Okay.
I have 2 more.
Whoa, that can't be right.
Did you get negative 2.56? Because that's what I got the first time, and I don't
That's
think
what
that's
I
right.
got.
Like, there's no way that's right.
I got negative
Well,
2.57 and negative 2.56 each time I did it.
Yeah, me
I
too.
think I messed up a number on one of those.
But I mean, if we're all doing that, like,
I got
Yeah.
negative 23. I got nothing.
Try it again. Negative 2.
I did that math wrong. So wait, so it's 3.3 minus 3.5 gives you negative 0.2, right?
yeah.
Mm-hmm.
And then square root of 81 is 9, so it's 0. 0.078 divided by that.
Yeah.
So negative 23.07. And then, so we want less than that. So the answer I got when I plugged that into the normal probability applet sounds crazy, but it's 3.941 times 10 to the negative 118.
Wait, what did you get for your z-score?
So I got negative 23 for my z-score. That's what I'm
Did you
confused by
do
here.
negative 0.2 divided by 0.078?
No.
Yeah, because you
So I
can't
did
have.
0.078.
That's
0.078 divided by 9?
Mm-mm.
No?
No.
Why not?
So on top you have 3.3 minus 3.5, which is negative 0.2.
Yeah.
And then
Yeah.
you're going to divide
And then on
that by,
bottom,
the bottom's 0.7 divided by 9, which is 0.078. So you do negative
but I thought our
0.2
standard
divided by
deviation, I thought our
0.078.
standard deviation was 0.078 though.
It is. So you have,
So,
so 0.7 divided by square root of 81 is 0.078.
right.
So that's
And
what's on the
so since
bottom.
that's our new standard deviation, wouldn't we do 0.078 divided by 9? Or a square root of 81?
No, because we
No,
already
because when you
did
do
that.
0.7 divided by 9, you get 0.078.
Yep.
Yeah.
Because 0.7 is
But
your
we
standard
said that,
deviation that we have.
That's after you do it.
Yeah,
but,
that's after you get it.
okay. But, so in 13, we found the standard deviation
Uh-huh.
for our sample population, right?
Mm-hmm.
So wouldn't that be the new standard deviation that we use?
No,
Like
because,
I am so confused.
well, that's what you use on the bottom. You don't have to divide it by 9 again, because you already did.
Yeah. That's what
But the
we,
whole
yeah.
purpose of
That's what
doing that
we
was to
found the bottom of
find.
it.
Okay, I thought the whole purpose of that was to find the standard deviation.
Because they gave us 0.7 as a standard deviation
Right, but that was for the
at the
left
very beginning.
skewed thing, wasn't it? That was for the left skewed population.
Because we're still looking at the same thing.
Yeah, but we can't
Just
use the
different.
normal probability applet for a left skewed population, which is why I'm confused.
I don't know.
Do you know what I'm saying? Like, am I making any sense, or am I just like off on my own little world somewhere? I'm just gonna go with you guys because my answer was definitely wrong. So what was 14?
I got negative 2.56 for the z-score.
That's what I got.
Yeah,
And
me
it's
too.
like
I got 0.57, but I redid it and it's 5.6.
Okay.
Okay, so then we plug that into the normal probability applet,
Uh-huh.
Mm-hmm.
and it
And
gives us
with, yeah.
0.005.
Yeah.
Yeah.
All right, so last one.
Mm-hmm.
Okay, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? Oh, well that's nice.
That's
Isn't
just
it
the
just
other side.
995?
Yeah, 0.995.
Yeah.
Alright, hopefully we actually know what we're doing.
Oh man.
What was that?
Hopefully we actually knew what we were doing.
The moment of truth.
Yeah.
I think number 5 is wrong, but that was it.
Come on. Oh, yeah.
5 was wrong.
So it looks
Sorry,
like
guys.
distribution of sample means. Don't know why, but we did pretty good, guys.
Yeah. Sweet.
Cool.
Wait, so why is the distribution of sample means?
I don't know.
Bummer. I feel like since you just took the quiz, you should be a professional at this.
Yeah, I don't know about that.
Oh well. We did pretty good for being confused half the time.
Yeah, we did.
I know we figured all of them out with
Yeah.
that one.
Yeah. All right. Well, see you guys Monday.
Yeah. See ya.
Yep. Monday.
Cool.
Awesome.
Awesome.
Bye, guys.
Bye.
See ya.